Welcome back. This is Mr. Hassan's Maths channel, and I am now going to answer a question from one of my end of topic worksheets from M1 Mechanics 1 on the Edexcel syllabus. This is a question from my momentum and impulse end of topic worksheet. This is question 2 from that worksheet, and it corresponds to question 7 from the Solomon C collection of past paper questions. And this question here is about two particles, A and B, of mass 3m kilograms and 2m kilograms respectively. They are moving towards each other on a rough horizontal track. So it's a rough track. So we've got to maybe consider something about that. Why did they say rough? Obviously, normally it says smooth here. So rough obviously means there's going to be some friction involved somewhere in this question. Just before they collide, A has speed 3 meters per second and B has speed 5 meters per second. Immediately after the impact, the direction of motion of both particles has been reversed and they are both traveling at the same speed v. Show that v equals 1 meters per second. Okay, so we have these two particles which just before they collide have particle A and particle B. Particle A has a mass of 3m kilograms and particle B has a mass of 2m kilograms. They are traveling towards each other. So according to my diagram, A is moving to the right and B is moving to the left. Okay, that's according to my diagram. You could have drawn them the other way around. It doesn't, it shouldn't affect anything in the question in the end. Okay, now, so this is the situation before they collide. And after they collide, what happens is they have reversed in direction and they're going now at the same speed but in opposite directions. Okay, so what I'm going to do here is I'm going to take the right as positive. Okay, I always state what I'm taking as positive. And I'm going to use the fact that the linear momentum before the collision, the total momentum before the collision of both particles and after collision has been preserved. So the total momentum before and after will be equal to each other. So if we take the total momentum before the collision, you've got the mass, which is 3m, times the velocity, which is positive 3. We're going to take into, this is velocity, so we're taking in terms of its direction, very, very important here, plus the momentum of particle B, which will be 2m, times its velocity. Now it's going in the opposite direction to A. I've taken A's direction as positive, therefore B's direction has to be negative. That's going to be negative 5 equals, and then you've got the total momentum of A, which is 3m. Now that's going in the negative direction, so that's going to be a negative value. So I'll put negative V here. Okay, that's going in what we call the negative direction because it has had its direction reversed. But we've got the B, which is now going in the positive, what we call positive, because its direction has also been reversed. So that's going to be positive V. Okay, so that's very important for us to realize that these two must have opposite signs because they're going in opposite directions. All right, so now we have 9m minus 10m equals minus 3 mv plus 2mv. So that's going to give me minus m equals minus mv. If you divide both sides by m, you end up with v equals 1. So v equals 1 meters per second. And there's the answer to this question. Okay, there's the answer to this question. V equals 1 meters per second. And that's number 7, part A. And it says show that v equals 1 meters per second, and we've done so. Okay, then it says the magnitude of the impulse exerted on A during the collision is 24 Newton seconds. Find the value of the mass m, what this big M stands for. Okay, so the impulse exerted on A would be acting in this direction because it's what's changed its direction, and this impulse is equal to 24 Newton seconds in terms of its magnitude, right? But because it's acting in this direction, because it's opposing the motion, or the initial motion of A, the impulse is what changed its motion, so it acted against the way it was moving. It's going to be negative according to our convention here. So I know that the impulse of an object is equal to the change in momentum. So it's m times the final velocity times, in brackets, the final velocity minus the initial velocity. In our situation, our impulse is negative 24. Our mass, okay, we're considering A. If we consider A only, okay, if we consider A, our mass is 3m. 3m. Our initial velocity was, the initial velocity it was moving at, which is 3 meters per second. 3 meters per second. And our final velocity was, in our situation, it's negative 1 meters per second because it's going in the opposite direction to what we call positive. So if we take all of that into account now, we can say we have negative 24 is equal to 3m, which is the mass, times v, which is minus 1, minus v, which is minus u, sorry, which is minus 3. Okay, minus 1, minus 3. So we have minus 24 is equal to 3m times negative 4. So minus 24 equals minus 12m. Therefore, m is equal to 2. So the value of m is 2. So there we've answered part B, using the fact that the momentum, the impulse is the change in momentum. Okay, so you've got to be very careful about the signs again. The momentum acting, the impulse acting on A is opposing its motion, so it's acting in the opposite direction to which A was initially moving. Therefore, according to the convention that we use, it's going to be negative. And so therefore, we have to be very careful with these signs here. Okay, that's something that a lot of people get messed up with in these questions. The signs of these, values. They just put the magnitudes in without thinking about the fact that they are vector quantities, and it will affect the answer. Okay, then it says part C. It says given the coefficient of friction between A and the track is 0.1. Find the time taken from the moment of impact until A comes to rest. So A is now going to be moving. It's gonna hit B, and then it's going to go along this in this direction. Okay, according to our diagram. Now we know the m is 2, and this is 3m. So this must be 6 kilograms. So this has a mass of 6 kilograms. This is A. And it's going to move for a certain while until it comes to rest. So it's starting off with the initial velocity. Okay, now I'm going to take this direction as positive now in this question because it's moving in this direction. Right? So I'm going to take this direction as positive as it's moving in this direction. Okay, we're taking a new situation now where it's moving. So we're going to take to the left as positive here, or the direction that A is moving in as positive. So we want to find the time it takes to come to rest, which will be when v equals 0. Okay, the initial velocity is going to be the velocity it was moving in after the collision, which is 1 meters per second. And we need to find the time it took for it to come to rest. So what we need to do here, because we can see that it's going to be undergoing another force of friction. Okay, there's going to be friction acting. That's the only force acting on it now. After it's being collided, there is a force acting on it which is going to cause it to decelerate, and that is a frictional force. Okay, and to work out the frictional force, we have to know what the reaction force is. So we have the weight, it's in contact with the surface, so we have a reaction force. So the weight is 6g, and we have the reaction force, and we have the friction, and which is the maximum value friction can be because it's actually moving. So we know that F max is equal to mu times R, where mu is the coefficient of friction. So we can say F max is equal to 0.1 times, and we know the reaction force is basically, if you resolve upwards here, it's going to be equal to 6g. Okay, so 0.1 times 6g. Okay, so F max is going to be 0.6 g newtons. So that's F max. Okay, so what we can do is we can set up an equation. We can say that if we take that side as positive, resolving in that direction, we can say that what we have is S U. In fact, what we can do is we can find the acceleration. We'll do that as suvat later. What we can do is we can say that if we resolve the forces on this object, then the only forces acting on it, the resultant force, is negative 6g. Okay, and that's equal to its mass times its acceleration. And the mass is equal to, we're using F equals ma. The resultant force is equal to mass times acceleration, and we know that the mass of this object is 6. So it's minus 0.6g is equal to 6 times a. Therefore, a is equal to, if you divide both sides by 6, negative 0.1 times g. So that's the acceleration. I'll leave it in this form, minus 0.1 g. And then what we can do is we can use the suvat equations. And we can write down what we know. We don't know s. We know u is 1 meters per second. Okay, we know v is 0. We know a is 0 is negative 0.1 g. And the time is what we have to find. So if we look at what we have here, we have u and v and a. We've got to find t. Well, this is a pretty simple one. V equals u plus a t. So v is 0, u is 1, plus, and you got negative 0.1 times t, 1g, times t. Okay, careful about that. So you have 1 plus, and you got negative 0.1 g times t. Therefore, you can say t is going to be 1 over 0.1 g. And so we can write down the time. So we have 1 divided by 0.1, which is going to be 10g. 10 times g. Nope, sorry. 10 over g, not 10 times g. My bad there. What am I doing? It's going to be 10 over g. 10 divided by g, which equals 10 divided by 9.8, which equals 1.02 seconds. 1.02 seconds. I've rounded it to 3SF. Okay, it doesn't tell us how to round it. Okay, so that's fine. You could leave it to 1SF, 1.0 seconds, but 3SF would be better for you to leave it so that it's just safer. All right, you will get your answers accepted for 3SF even though you use G, although really, it's right to put it to 2SF because we use G as 9.8. Okay, anyway, so there's your answer to that question. I hope that was clear. The student asked me that question. Hopefully understood it now. He actually only asked for part C, which is more to do with, kinematics and, suvat equations. But we need to, of course, apply that to all the different topics that we get, right? This, you can't just do each topic separately. They're going to apply, sometimes one question comes up in another topic. All right, so that concludes this question. Other questions from this particular end of topic worksheet, I have collected the answers in the playlist over there, the ones that have been asked about. Some of them might not be answered yet. Other questions from this topic of momentum and impulse from M1 in general, all the questions I've answered about that from different various sources will be found in this playlist over here. You can subscribe to my channel by clicking on this link, and you can watch a video that will appear over here that tells you how to use my channel in an effective way. Thank you for watching and see you soon.